Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to present the effect of bentonite and carbon active from coconut husk additives for wastewater treatment, which is written by myself, Ari Karya Utama, and Hafid Paramadika, Bayu Satyawira, and Samsung. Introduction. In the oil and gas industry, the wastewater side product that needs to be disposed properly has to be treated to meet the government environmental codes. One method to treat the wastewater is by using adsorption process. Adsorbent used in this laboratory research are bentonite and carbon active material. Bentonite is a common absorbent in the oil and gas industry. Carbon active material used in this laboratory research is made from coconut husk. The result shows that coconut husk gives better result than bentonite. The method starts with preparing the apparatus and the material preparation, and the material are a bentonite on this right picture, which is a common drilling mud, and then coconut husk on the left side, and then first of all we measure the water for its TDS, salinity, and pH, acidity, and then we prepare the absorbent for 0.5 gram per cc, 1 gram per cc, 2.5 and 3 gram per cc concentration on the wastewater for each of the absorbent. And then we measure the TDS, salinity, and the pH of the mixture, both. And then that's it what we do in this lab. Bentonite and coconut husk were cleaned and filtered to 200 mesh for bentonite and 100 mesh for coconut husk. Filtered bentonite and coconut husk are being activated by using 1 mole HCl fluoride. Both absorbents were each being stirred in 1 HCl and then being cleaned and dried. These dried absorbents then were used to be mixed with wastewater. And then the wastewater TDS were measured by using TDS meter in ppm unit, part per million unit. And on the right is the wastewater sample. And the salinity was measured by using salinity hydrometer in a part per 1,000 unit. And the pH was measured by using a litmus paper. The adsorbents were mixed with the wastewater sample at the concentration of 0.5, 10, 2, 2.5, and 3 gram per every cc of wastewater. The TDS, salinity, the pH of those mixed samples were also being measured, and the measurement result for each parameter, both for both bentonite and coconut husk absorbent, were different. And then the result and discussion. Below is the summary of the wastewater with absorbent. The wastewater itself, acidity is 9, and the total dissolved solid is 5,750 tons part per million, and the salinity is 24 part per thousand. And then we increase the absorbent concentration from 0.5 gram per cc to 3 gram per cc. And then we can see here the bentonite, both bentonite and husk decrease the acidity, decrease the pH, the acidity, the pH number decrease, and it's tend to close to neutral. And the bentonite, the TDS of the bentonite and coconut husk decrease sharply. Both of them decrease sharply, and in the end, the coconut husk is decreased more as compared to bentonite, under 3 gram per cc. And then the salinity also At first, the coconut husk doesn't change much on the 0.5 gram per cc of coconut husk. And then finally, we end up with taking 11 part per thousand of salinity using coconut husk. And as an engineer, usually we try to explain it with the graph. But the red one is the wastewater, the green nut is mixed with bentonite, and the coconut husk is a green one. And we will have the same color along this presentation. This is the effect of absorbent toward acidity. And then you can see the acidity decrease toward a neutral. And then you can see here, neutral is 7. It's understandable since both absorbents were being activated by using 1 mole HCl. The acidity instantly reduced the pH of 8.5 for bentonite and 8.1 for coconut husk. The acidity became 7.2 for both sample and the 3 gram per cc concentration. And it's the same 2.5, 7.3 gram per cc concentration. And then this is the result of the total dissolved solid with the same color scheme. So the TS due to both absorbent instantaneously decreased significantly, especially with bentonite. Okay, but bentonite additive doesn't change much with the increase of absorbent concentration. So whatever we adding up the concentration of bentonite, there is no change, significant change on the TDS. However, for the coconut husk, decreased from around less than 4,000 to become 2,500, around 2,500, which is lower than the effect of the bentonite. So there is a decrease significantly on the coconut husk. And then the salinity due to both absorbent decrease as absorbent concentration increase. So you can see that the decrease of the salinity as the concentration increase. But coconut husk doesn't change much when we have 0.5 gram per cc here. And then it is reduced a little after 1.5 and then significantly reduced to 11 on the at the end of the 2.5 and 3 gram per cc absorbent concentration of the coconut husk. Meanwhile, on the higher addictive concentration and salinity is significantly expressed in the coconut husk. But on the bentonite, there is no change on the salinity. If we add more concentration, there is no change of salinity. And conclusion recommendation, acidity reduction due to both absorbents along with the increase of absorbent concentration causing the acidity close to neutral. The increase of bentonite concentration had no effects on the TDS of wastewater. The increase of coconut husk reduced TDS. The TDS with coconut husk passing TDS with bentonite at 3 milligram per cc concentration. Half gram per cc coconut husk concentration did not change the salinity. However, above 2 gram per cc coconut husk give better performance than bentonite in salinity reduction. Both absorbent did not reduce salinity more for concentration above 2 gram per cc. Coconut husk is comparable to bentonite in performing reduction pH, TDS, and salinity. Performance of coconut husk were better than bentonite in the concentration of 2.5 gram per cc. It is recommended that the absorption of the hydrocarbon emulsion in the wastewater should be determined in order to see the best absorbent for wastewater sample. And thank you for your attention. I'll be happy to accommodate your question. Thank you.